Thank you so much. Hello and good morning, everyone. Thanks for joining me at this SREcon presentation this morning. My name is Vanessa Yu, and I'm from Goldman Sachs. I've worked at GS for 15 years, across a number of different engineering roles, mainly in the infrastructure space. And I currently manage the SRE team for our critical infrastructure services. This includes products such as our security, authentication, and entitlement platforms, as well as our directory services. I also co-head the European Women in Engineering Network at Goldman Sachs. Well, this is my first SREcon presentation, so I'm super excited to be here, and thanks for joining me as well. And in today's talk, we're going to be discussing how to deal with dark debt, which is a special form of technical debt, and one of the key themes for this year's conference. So here's the agenda for the presentation. I know some of you might not be that familiar with us because this is the first time GS has attended SREcon. So I'm going to spend a few minutes talking about what we do. We're going to then spend some time covering the concept of dark debt, what it means, and how it is different from the usual technical debt. The bulk of time in today's presentation is then going to be spent on discussing a few key themes which can hopefully help all of us to manage our dark debt better. And then we'll also do Q&A at the end. For those of you who are not familiar with Goldman Sachs, we are a global financial services firm that offers investment banking, securities, and investment management services. That means we cover everything from IPOs, mergers and acquisitions, sales and trading, through to asset management and investment research as well. We also have an online retail bank called Marcus, which has been operating in the US for the last 2 years and had literally just had its soft launch in the UK last week as well. Our company was founded in 1869, and we currently operate in over 30 countries with about 38,000 employees globally. And at this point on the slide often surprises people when they hear about us, which is that 1 in 3 of us at Goldman Sachs are actually engineers. In fact, engineering is the largest division in our firm. We have software development teams aligned to every one of our businesses, as well as core engineering teams that build platforms and infrastructure that span across our whole organization. And this, of course, includes SRE. On this slide here, I've included some figures to give an indication of the size of our footprint. There's probably some eagle-eyed members of the audience who spotted this from the day earlier on, which is our firm is going to be 150 years old next year. And over time, we've really amassed a really diverse environment with a combination of in-house developed systems, vendor software, open source products, and both internal and external facing systems at all levels of maturity. And to top it all off, the size of our plant and also the volume of data that we manage every day is constantly growing. So as SREs, we help our firm run at scale, as well as manage system risks and complexities in our environment. Reliability is absolutely essential to us, not only because we have to keep our businesses running day in, day out, but also for us to meet all of our service levels, as well as our regulatory requirements. So now let's move on to talk about debt. Now, I'm sure technical debt is not a new topic to this audience. We've all kind of dealt with and managed it day in, day out. Technical debt is basically what we incur when we make compromises during software and systems development. They're mostly driven by user demands or time-to-market pressures. So for example, we might be in a hurry to get a business feature out the door and release something that we know has some issues that we're going to have to go back and fix later on. We also know that unless we really do go back and fix those issues, this debt is really going to accumulate with interest and slow us down over time. In other words, it becomes increasingly difficult for us to manage changes and make changes to our systems because of bad code or design decisions from the past. Now, technical debt is something that typically we can measure, and we know it can be addressed by refactoring. So how is dark debt different to this? In basic terms, dark debt can be described as a form of technical debt that is invisible until it causes failures in our systems. The Stellar report, which first coined the term last year, actually describes dark debt as liability that arises from unforeseen interactions of hardware and software with other parts of the framework, which is not recognizable at the time of creation. In fact, dark debt draws its name from dark matter in the universe, which has observable effects on our environment, but cannot actually be seen or detected directly itself. Now, when I first saw this theme on the CFP for SREcon, I was intrigued, because I've got to admit that I had never actually heard the term before. But when I read the Stellar report, I recognized what this meant straight away, because I'm pretty sure everyone here who's managed distributed systems would have been caught out by this at some point or another. So are there things that we can actively do to mitigate or manage this form of risk in our environment? So in this talk, I'm going to focus tactics to manage dark debt around 5 key themes: prevention, getting insight into your environment, detecting and debugging issues, as well as some cultural considerations. And I will try and illustrate each of the themes with some of the tools that we have either built or adopted at Goldman Sachs to help us manage our environment. So first up, now we've all heard the term prevention is better than cure. So the first theme I'm going to cover is on building sustainable development ecosystems. And by that, I mean ecosystems which inhibits the creation of technical debt to begin with. And to do that, I'm going to tell you a bit about SECDB. So what is SECDB? Well, it stands for Securities Database, where securities here means being in a financial instrument sense rather than technical. And it is the central risk management platform for Goldman Sachs. Despite its name, it is actually much more than just a database. It is, in fact, a complete ecosystem for evaluating, pricing, analyzing, and storing financial instruments. SECDB underpins every one of our businesses, and thousands of users at GS use this platform to run risk calculations, do financial modeling, price their trades, and manage their books every single day. At the core of the platform, there is actually an object-oriented database, along with a dependency graph. It also has its own proprietary language called Slang, the securities language, which also has its own IDE. Now, you might be wondering what all of this has got to do with sustainability. So here's the key point. SECDB and Slang were created a quarter of a century ago. But despite the number of years it's been around, it is still constantly evolving on a daily basis. We refer to SECDB as just being 2 weeks old because we build and release a new version of it every fortnight and have been doing that for decades. Now, many other technologies have kind of come and gone at our firm over the last 25 years. So what is it that makes SECDB so successful at Goldman? One of the key differentiating factors which has kept SECDB running and becoming such a powerful platform across the entirety of our firm is the fact that it was designed to be transparent and collaborative from the get-go. Every developer at Goldman Sachs, irrespective of which team or which business they're in, can read the SECDB code base and see all of its dependencies. And even though we have write controls in production, for obvious reasons, fundamentally speaking, everyone can also write and execute all code locally. This means our developers can contribute bug fixes to pretty much any problems that they find in their environment. they have the capability to enhance existing code to avoid duplication, and they can also develop tools that others can leverage and reuse across the firm. Now, all of these are really good development practice that fosters reuse and help prevent redundant code and technical complexity buildup in the environment. In addition, we've also made huge investments over the years in linting and instrumenting SECDB. For example, we instrument the whole of the SECDB runtime environment. So for every SECDB session that's run globally in Goldman Sachs, we know exactly what had been used, when it was used, and how. We then use all of this data to build tools to manage risks and complexity of the code base as well. So for example, we have automated bots that will actually go in, scan, flag, and then remove code that's been unused for a defined period of time based on your tuning. Now, this is particularly useful in fighting dark debt because you really don't want deprecated code to sit around in production and run the risk of it being activated accidentally down the line when your systems change. In fact, if you read the Stellar report and look at some of the incidents that's highlighted, which has dark debt signatures, this was often one of the key contributing factors to the root causes of those problems. Another feature we have are fix-me comments, which is actually a no-op function in slang with the sole purpose of documenting and tracking technical debt in our code. For example, if I needed to hard code a value temporarily, I can put in a fix-me comment which says, replace this with a constant, add a due date of when I should fix it by, and put down the owner of the fix as parameters. The system will then just automatically start tracking this for you. Each team has full transparency of all outstanding fix-me's along with the aging information. And they're also flagged in code reviews if anyone wants to change that code. This, of course, helps ensure known issues are not just left festering and forgotten about to become dark debt. And also, the code reviewers will apply the due diligence to make sure that these issues are actually fixed as well before we do further releases. And just to make things a bit more fun and competitive, we also have leaderboards that track who has made the most improvements to the code base. And we reward more points for removing code than releasing it. So we actually have many more examples of these tools, which our developers have developed and created for each other over the years. Things that flag cyclomatic complexity, things that find deprecated functions. We publish code quality metrics across our whole firm. The list goes on. But fundamentally, building a fully transparent ecosystem, incentivizing the right practices, and allowing your developers to build tools to help each other and maintain the overall health of the code base goes a really long way in ensuring you have self-sustaining ecosystems with less technical debt over time. So at this point, you might say, well, that's just one platform at Goldman's. So what about when your environment is non-homogeneous? Having talked about development ecosystems, now let's move on to talk about our production environment. In large enterprises like us, getting a consistent view of runtime is pretty challenging. But having monitoring tools, which are decoupled from our applications, allow us to scale and do this more effectively. Now, GS is a pretty big Java shop. On any given week, we run an average of about 25 million Java processes. We have hundreds of Java applications, all owned by different teams with different release cycles. And historically, everyone had to kind of fend for themselves when it comes to monitoring. Now, this was clearly problematic for us. Teams ended up implementing their own bespoke monitoring solutions, or actually, in many cases, no monitoring at all. And in the meantime, repeat issues kept cropping up and catching us out in the same manner across different parts of the organization. So to tackle this, we built the Java Runtime Monitor, JRM for short. It is basically an agent that we embed into the JRE, such that whenever you launch Java anywhere at GS, the agent will start and monitor your processes for you. The agent is centrally managed, so it requires no effort from any application owners on deployment, upgrades, or version control. So aside from JMX performance monitoring, we also capture beaconing data, like system properties, JVM arguments, code source path, as well as the product name and the version data that's appended to classes during build time. We then deploy a consistent configuration baseline to all agents, but also give developers the flexibility of adding their own application-specific metrics on top of that. Now, we currently collect around 150,000 data samples per second. All of this data is ingested, processed, and enriched centrally. For example, we map all of the beaconing data against our internal application directory and topology. This then allows us to do application-specific forecasting and predictive analytics on utilization patterns. We can also run things like library usage discovery across our entire plant. A powerful aspect of JRM's design is that the configuration of the agent is completely decoupled from its source code. So we can reconfigure and tune the agent without changing anything in the JRE itself. This is important because then we can maintain a separate release cycles for our config and have a quick way of disabling and enabling the agent as and when needed. The fact that we can monitor horizontally across our whole environment means that when we discover issues, we know straight away where we have exposure and can deal with it quickly. For example, let's say if our tech risk team comes to us and says that there is a security vulnerability with a third-party library, we will run our analytics and know straight away where it is being used and which businesses are impacted, and can then target our remediation efforts accordingly. All of this ensure we have less blind spots in our environment where dark debt can actually hide. The next topic I want to talk about is around detection of dark debt and chaos. I'm sure most of you in the audience have heard of chaos engineering, which is defined by Netflix as experimenting on a distributed system in order to build confidence in its capabilities. Now, admittedly, the financial industry as a whole is not a big adopter of chaos engineering. But for some of our newer internal systems, we're now starting to embed this in by default. For example, we have an infrastructure provisioning system which will reject a certain percentage of orders randomly in production. This helps to ensure all of our retry logic and error handling between all subsystems are in good working order, and that there's no adverse service level impact on the overall performance of the whole flow. As a firm, we've also been practicing fault injection to stress test our business systems and applications for a very long time. Now, I know fault injection and chaos engineering are strictly speaking the same thing, because chaos engineering is much more focused on the experimentation aspects. But the underlying principle of breaking things on purpose in order to expose weaknesses in our systems is fundamentally the same across the two. Now, I wanted to touch on these in particular in this presentation because I feel that they're especially effective in uncovering dark debt. They're the forms of tests that can typically help you flush out unforeseen interactions or hidden dependencies between different components in your stack, which would be really hard to achieve with the traditional unit and integration tests. The key thing to bear in mind, of course, is that our systems are constantly changing. So you can't really afford to be complacent just because your experiment or your test found a problem at one given point in time. We also have to constantly reevaluate and recalibrate our tests in order to make sure that they remain effective. Sometimes, despite best intentions and efforts, we will still be caught out by dark debt. So it's pretty important to ensure we have the right tools to debug issues when they crop up, so especially if you're woken up at 3 a.m. in the morning. So one of the most effective ways to do this in distributed systems is to use tracing to visualize and hone in on problems in your environment. Now, traditionally, if we saw a sudden jump in resource utilization or latency spikes in production, we would go to logs to try and figure out what's going on. But most of our services are now running in massively distributed systems with a high degree of concurrency. So correlating these events have become increasingly difficult. So we have started implementing distributed tracing to complement our centralized logging to help us observe what's going on at request level. Just a quick 1 minute on terminology in case there's members of the audience not familiar with the technology. So distributed tracing relies on traces and spans. A trace is the complete processing of a transaction from service entry point to end of execution. It consists of one or more spans, which are units of work executed in your system. The key idea is to give each request a unique trace ID and propagate it consistently across all services and components of your distributed system. So you can visualize the whole request lifecycle end to end, like in this diagram. You can also enrich the spans with metadata, which can help contextualize the task that's being performed. And this information can often also help you with the troubleshooting. Now, most of you probably recognize this as being Zipkin, which is actually based on the Google Dapper paper. So here's a trace for a request in one of our distributed data stores. And in fact, it came from an incident where we saw intermittent latency spikes across a small subset of requests. Now, the emphasis here are the terms intermittent and subset. Now, in a system where we're processing thousands of requests per minute across multiple database shards, it is very time-consuming to debug and correlate what exactly is causing these type of random spikes. However, as you can see above, when we put in the trace ID for one of the requests which was erroring out, we saw straight away that the latency is occurring in one particular shard. And because we also logged the actual database query that's ran against each span, we were able to identify the trigger which caused this problem much more quickly. So what actually happened here is that even though our data store and the queries themselves had not changed at all, another system had injected millions of new rows of data into the storage tables due to a regulatory project go-live. The stats against the new tables had not been refreshed yet. So the database query optimizer ended up running an inefficient query plan and did a full table scan. This then maxed out the load on the shard and slowed down a portion of our requests. This is like a real classic example of getting caught out when systems change underneath us and causing unintended impact. And whilst in this particular case, we weren't actually able to prevent the issue from happening, we were able to pinpoint and resolve the problem much more quickly with the right tooling in place. And this is just for a bit of a laugh. So I decided to throw in a deep retry chain. This chain actually goes on for about like 600 plus spans, and I genuinely couldn't fit it all on the one slide because it was like this long. So again, to reiterate the point, there are problems which become immediately obvious when you can see it displayed visually. The last theme I want to cover today is culture. Because when it comes to technical debt, not all of it is to do with technical implementation and tooling. Just like with the SECDB example that we covered at the beginning, fostering the right culture and practices in your organization is equally important when it comes to preventing and mitigating dark debt. So in this section, we'll talk through a series of do's and don'ts in terms of cultural practices. Well, start off with what not to do. Firstly, No matter how much you love this game in amusement arcades, don't play whack-a-mole with your systems. In other words, don't perform random heroics and chase down every single edge case in your environment. When bad stuff happens in production, I often see people jump into action and try and patch things and patch every possible iteration of the problem. Well, unfortunately, this isn't always the right thing to do, and we really need to hold ourselves back and avoid knee-jerk reactions. Most of the time, these niche fixes for one-off edge cases end up being bad investments that will basically become obsolete as soon as our system changes. As the systems change, all of our edge cases change as well. And I definitely have scars from incidents where these things have become dark dead and caused outages as well. Now, alerting holistically on SLO risk and having the right instrumentation and tools to help diagnose novel failures is a much more sustainable way of managing risks in our platform. Say no to dark matter developers. I think we've all experienced this one. Perhaps someone in your company had developed something, but when they leave, the rest of the team is ended up scratching their heads, digging around, trying to figure out what they did and why. Does that sound familiar? Yeah, I see nods. Now, SREs care about reliability and eliminating single points of failure. The lesson here is that we mustn't allow our developers to turn into single points of failures themselves. No one should be developing in isolation or keep knowledge in their heads about how to operate systems. This is kind of like the perfect recipe for cooking up some dark debt that we should really, really try to avoid. Don't ignore your technical debt. Now, this one is super obvious, right? But I wanted to give it a shout out because we know everyone is always busy, and we often just end up deferring and then forgetting about technical issues in our environment. So going back to SECDB, having features like Fix Me, where you can document and track issues as you are developing, is really useful to make sure they don't get forgotten about and become dark debt later on. So now here's a few things that we should do. Increase runtime transparency. Hopefully, you will have noticed that transparency is a recurring theme in this presentation. By adopting and building tools which give you better transparency and control over your runtime environment, you can definitely help minimize blind spots where dark debt can catch you out. Practice blameless postmortems. Now, this is such a key part of SRE that I really hope it doesn't need explaining to this audience. It is so important to build a culture where people are not afraid to talk about their failures. Because if you're hit by dark debt, then the likelihood is that it's hidden elsewhere as well. And sharing this information is really a key way to prevent it from happening again. At GS, we actually have a weekly forum where different stakeholders and SRE sit down with our CIO to review postmortems for our highest impact incidents. This kind of helps facilitate knowledge sharing, and we also use the forum to discuss prevention strategies. Try to encourage everyone in your teams to learn from each other and be transparent about their design decisions. Pair programming, in particular, is a great way for junior members on your team to learn as well. This is also particularly effective at killing off those dark matter developers from the previous section. And finally, run SRE hackathons or dedicated sprints for refactoring. We all have issues that we put on the back burner, or wish lists of things that we know we'd like to fix. Always look for ways to turn risk elimination into something fun that the whole team can get behind and tackle. This way, you have happier developers who are less burdened or burnt out by technical debt in the long run. So to recap, here are the themes that we've covered today. And hopefully, when all of these concepts are applied and working together, you will have a much more transparent system with less dark debt waiting to catch you out. Please come and visit us at our booth if you want to find out more about our SRE teams and what we're working on. Thank you very much.